All right, here we go. Today is 9:25, and we are looking at combinations of functions, applications of combination of functions. You can see not a lot of work to do today.
Woo! Thank you, Miss.
But it is Wednesday, so you might not finish.
Go!
All right, here we go. Y'all are slow.
Okay, cool. Gotta go fast.
You good now?
Do you remember the Jake in middle school? And like he had to.
Alright. Example 1. Find two functions. Find two functions f and g such that f of g, that's fine. F of g of x equals h of x.
It's okay, she's a teacher.
That's funny. Okay. Okay, so first of all, they're telling us that f of g of x equals h of x. What does f of g really mean? Of g of x. The inside is g of x, and that equals h of x. All right, now, what that means is if I have this, I'm trying to find this g of x function, or this g function, that I want to plug into the f function. So I like to think to myself, hey, the g of x is on the inside, so I want to look for an inside g function, and I need an outside f function. And when I compose the two, when I put one inside of the other, it's going to equal the h of x function that they gave me here. So I want it to equal 1 over radical 3x plus 1. Okay, now, first of all, you should know there are like an infinite number of right answers here. Okay, but I want to see the easiest one right off the bat. Look at this result here. Give me something that's from the inside. What if it was just the radical? What would be on the inside? Oh, good. Okay. The inside of that result thingy, could you say that 3x plus 1 is on the inside? Okay, so I'm going to say, hey, I want to let my g of x function be 3x plus 1. Now, I need to take that g of x function, that 3x plus 1, and I'm going to plug it into my f of x function. What should I plug it into so that I get this result? 1 over radical x. Very good. Why? Because it's too easy. Here you go. Watch what happens. If I do f of g of x, what's g of x? 3x plus 1. So I'm doing 3x plus 1. What does f of 3x plus 1 tell me to do? Plug in 3x plus 1 to the f function. So I'm going to plug that in there. What do I plug in place of the x? 3x plus 1. And what does that equal? H of x. Done. All right. Is that the only answer? No, there's lots more. Lots more answers. Okay? You only need one of them. All right? But could I say, what hey, what if g of x is just 3x? What would I have to plug it into to get our result here?
1/x+1.
Yes.
Ah,
Yes.
big brain.
1 over the square root of x plus 1, because this 3x would be placed in place of the x. Do you see it?
Yeah.
So if I just take the 3x as my inside, all right, what's left over? 1 over radical something plus 1. I'm going to take that, and it would be plugged in when I do the composition. Does that kind of make sense? There's lots of different ways to do it. Yes, yes. And in fact, I could add, plus ones and minus ones all over the place and do it forever. Lots of it. All right. Here's another one. We need an inside function, and we need an outside function. What's on the inside?
2x plus 3.
Yeah, sure, right there. 2x plus 3. What would I have to plug that into? X to the 4th.
Oh, it's not. This is humiliating.
Is that the only option? No, there's lots more. Try another one just for giggles. What if I'm just using 2x? What would my f of x be?
X plus 3 to 4.
To the 4. Very good. Yeah. Again, that gets plugged into the x there, and voila, we get our h of x function. Okay? Lots of options. All right? This should take you 2 seconds to do. Super easy. Okay? All right, very good. Let's do some word problems, because this is our real one.
I knew it wasn't going to be easy.
Calm down, everyone. It's gonna be alright.
If you close your mouth, then you'd hear me say, you don't need to copy down the word problem, because it's in your book on page 85. I think it's page 85. Can someone confirm that for me, please? Now, however, you will do the math, and maybe write down the equations, because those are important. It's not. Oh, there it is. 87. All right. Okay. Okay, here we go. Now, we're going to read along. I would recommend writing down the equations, and we'll do the math together and that sort of thing, but you don't have to write the word problem. All right. If you're going to write down these equations, then you also want to make note of what I'm going to talk about when I'm going to look at those equations. So here we go. The number N of bacteria in a refrigerated food is given by N of big T equals 20 big T squared minus 80 big T plus 500. T is between 2 and 14, where big T is the temperature of the food in degrees Celsius. So what does this whole thing, what is that referring to?
Temperature is bigger than you.
So again, this is temperature in degrees Celsius. So this is 2 degrees Celsius to 14 degrees Celsius, which is probably like about 33 degrees Fahrenheit to like 60 degrees Fahrenheit. Okay, somewhere around there. Okay, so when you're reading word problems like this, ladies and gentlemen, take the time to carefully understand what the letters mean. That is 90% of word problems. You'll know what to do if you read it carefully. What does the N represent?
The number of bacteria.
Yes, the number of bacteria. All right, and capital T represents temperature in degrees Celsius. So these are things that you write down and you make note of. Then, when the food is removed from refrigeration, what do you do when you remove food from refrigeration? You put it on the counter, right? Okay. You sit it on the counter, you start eating it, whatever, you dish it up, okay? The temperature of the food is given by T of little t equals 4t plus 2, where little t is between 0 and 3. What does little t stand for? Time in hours. All right, so why do you suppose they say this? The temperature, the time is between 0 and 3 hours. Why are they giving us that's very specific increment of hours from 0 to 3 hours? Yeah, because food shouldn't be left out. Very good. This is a recommendation. You should get your food in the refrigerator within 1 hour of cooking. Okay. Let me ask you another question. What is the shape of this function? It's linear. It's a line. Good. And do you think, if you're imagining this is the temperature of your food as it sits on the counter, so you took it out of the refrigerator, it's sitting on the counter. How cold is it? It's cold. It's like 40 degrees. That's what your temperature in your fridge should be at. 40 degrees Fahrenheit. Okay. So, and you set it on the counter. After an hour, you might expect it to be lukewarm. Okay, like what? The temperature of your room, maybe? Okay. If it's linear, is it always just going to keep getting warm? Does that actually make sense? Is the food going to continue to heat up in your environment? No, definitely not. The real reason this is limited between 0 and 3 is because this function only works for a limited amount of time. Your food doesn't perpetually warm up. All right? It stays at the temperature of the room. So this is an approximation, okay? That's really the reason why. But it's good to know. All right, so here's what we need to do. We need to find n of big T, which means n of big T of 2. What do they want us to do? What can I put in place of big T? What is T of little t? Oh, what can I replace T this?
14.
Yeah, there it is right there. 4t plus 2. 4t plus 2. And then what is n of 4t plus 2 telling me to do?
Plug in.
Oh, plug that into our n equation right here. And so we have 20. And what are we plugging in place of the big capital T? Yeah, we're plugging in 4t plus 2 squared minus 80. Plugging in 4t plus 2 plus 500. Okay. And what do we need to do? Multiply a bunch of stuff together, right? So, all right. I want to expand 4t plus 2. What is that? 16t squared. Good. 16t squared plus 16t plus 4. When you FOIL that out, I need to distribute the negative 80. So we get negative 320t minus 160 plus the 500. I need to distribute the 20. 20 times 16t squared. Plus 320t. Okay. Oops, I changed the sign. Don't do that. Minus 160 plus 500. And then we can, let's see, combine some like terms. 320t squared. Positive 320 and negative 320t cancel out. And we're left with 420. There you go. All right. So what does this equation give us? In terms of
Or the bacteria, the number of bacteria.
In terms of what is the variable I see? Little t. Very good. All right, so you'll notice how the notation, if you follow the notation properly, the n, we're still getting the number of bacteria. And then once you work all this out, the variable that we're using is t. That's really important. Little t, by the way. Little t. Lowercase t. Having the proper notation is really useful when we want to interpret the meaning. What does n represent?
Number of bacteria.
Oh, the number of bacteria. All right. In terms of,
How long it's been sitting out.
yeah, in terms of t, in terms of time out of refrigeration, I guess. Time out of refrigeration. Or how long it's been on the counter or whatever. Now, they told us that time had a limit. Yeah, between 0 and 3 hours. This only works when time is between 0 and 3 hours, and that's really important to understand. Okay, so that notation is actually really useful, and if you follow along, then it's really easy to actually interpret the meaning if you have the proper notation. Now, let's see what the next part is. Part B. Find the time the bacteria count reaches 2,000. Find the time the bacteria count reaches 2,000. Okay. What are they asking us to do here? All right, that's a find t when. Good. And so when you understand what the letters mean, bacteria was in 2,000. So I'm going to take our equation that we just found right there. N of t equals 320 t squared plus 420. And what am I plugging in?
2,000.
2,000 equals 320 t squared plus 420. Oops. And how do we solve? Subtract 420. All right, 2,000 minus 420 is 1,580. And then what? Divide by 320. All right, I can do that too. Divide by 320. And I get 4.9375. And then what? I have a calculator. Square root. What do you need to remember if you take a square root? Do you really need to remember it for a problem like this?
No.
No, why not?
Because time can only be positive.
Yeah, we can't talk about negative time. Boy, though, I really wish we could go back in time. That'd be pretty great. Yeah. All right. So I am going to take the square root of my answer and get 2.22. 2.222 equals t. What does that mean?
After 2.222 hours, it has 2,000 bacteria.
Good. After 2.22 hours, the bacteria has reached 2,000. I don't know what the unit is on bacteria. I mean, is bacterium a unit? I don't know how they count that. All right, I do one more here. Oh, no, you weren't done? Yeah. Oh. You know, first period didn't complain.
Sorry.
We're not as close as
I guess.
Once we complain,
Probably has.
wait, maybe, well, we complain like right now. What if they complain later?
Probably.
Oh, yeah.
Yeah.
It's too early for them.
All right, here we go. Last one. You should write this one down. All right, example 3. You should write this one down. They're more like this in your homework. Yes. A spherical balloon. You got a visual in your head there? Spherical. A spherical balloon. A spherical balloon is being inflated. And the radius of the balloon is increasing at a rate of 2 centimeters per second. And one thing I like to talk about is really this understanding of rate. And I talk about this with my daughter all the time. 2 centimeters per second means it's growing by 2 centimeters every second. It's growing by 2 centimeters every second. All right? Get bigger and bigger and bigger. Okay. A. Express the radius r of the balloon as a function of time t in seconds. Express the radius of the balloon as a function of time t. Okay, so I'm going to make a little chart. I had teachers who would just write up equations, and I never understood where they came from. So maybe you know right off the bat how to write this equation, but I like to do it a little more deductively. I want radius in terms of time. So time is important, and the radius depends on the time. So when time is 0 seconds, how big is the radius? 0. Okay. And then after 1 second, how big is the radius? 2 centimeters. Okay. And after 2 seconds, 4 centimeters. And after 3 seconds, it would be 6. What are we doing? Multiplying by 2, right? Is that 1 times 2, 2 times 2, 3 times 2? And so if we have t seconds, what do we have to do to get the number of centimeters? 2 times the t. All right. The other thing that you should note is that it's unit analysis. 2 centimeters per second. What do I have to multiply by to get the radius? Yes, we have to multiply by seconds, and that'll leave me with centimeters, which is what we're looking for, radius. So here, radius is equal to 2 times the time. If I wanted to, I could write r of t, because this is r in terms of t. So here is a great little equation. That's all they were looking for. This is radius as a function of time. Radius as a function of time. Radius in terms of time, same thing. All right. Just so you know, this is out of the calculus book that I work from. Part B. If V of r equals 4/3 pi r cubed is the volume of the balloon as a function of the radius, find V of r and interpret its meaning. What does V of r tell you to do? Plug in r. Yeah, V of r. R of t, I guess. There we go. All right. So we know that r of t is what? 2t, 2 times the time. Okay. And then what does V of 2t tell me to do? Into your volume equation. And so we're going to take 4/3 pi, and what are we plugging in place of r? 2t. So 4/3 pi, and what is 2t quantity cubed? 8t cubed, good. And I guess I can clean that up a little bit because 8 times 4 is 32/3 pi t cubed. Which means this is volume in terms of, what variable are we using now? T, yeah. So this is our equation, volume in terms of t. And what does t represent? Time. So the meaning would be what? What does V stand for? Volume. Volume of the balloon in terms of time in seconds. So this formula gives us the volume of that balloon every second, at whatever second we are inquiring about. Okay. Ladies and gentlemen, in your homework today, you might need to remember, what is the area of a circle?
Pi r squared.
Pi r squared. What is circumference of a circle?
Wait, what was that?
Circumference?
2 pi r.
2 pi r or pi d? Yeah. All right. You might need to remember those formulas. All right, ladies and gentlemen, I am going to pass out your tests, and you guys can do test corrections. Oh.